Hello, and welcome to the video for section 5.2, day 2, solving by substitution. We're going to start off by putting our name, date, 5.2, day 2, and I'm just going to write up here, solve linear systems by substitution. All right, so just a reminder what we're actually doing here, okay? If you remember from yesterday, our steps to solve systems, all right, we're gonna solve for one of the equations for one of the variables. Then we're gonna substitute the expression from step 1 into the other equations and solve for the other variable. Then we're gonna substitute the value from step 2 into one of the original equations and solve. And then we're gonna write our answer from step 2 and 3 as an ordered pair. So the steps are going to be today the same as they were yesterday. All right, we're going to fold our paper, both hamburger and hot dog, as you can see here. I have them separated into blocks. All right, so to start off, I'm going to start off by kind of giving some hints on what to look for here. So when we solve systems in this case, all right, we always want to look for a variable with a 1, and I'll even say if we can't find one with a 1 or a -1 as the coefficient. All right, that's going to make our life a lot easier. So once we do that, then we're going to solve for that variable. And then we're going to follow our steps for substitution. All right, those are the steps I just told you. All right, you should have those in your 5.2 day 1 notes. Okay, so we're going to solve these using substitution. So all of our examples today, so we're going to solve the linear systems using substitution. All right, in example 1, we're going to have 3x plus y equals -1. And our other equation is going to be -x plus y equals 3. Okay. So as we start off and look at this, all right, we have a couple of different, we have actually, y has a coefficient of 1 and x has a coefficient of -1, okay? So I would solve for y, and in this case, it wouldn't matter which equation we solve for y in. I'm gonna solve for y in the second equation. In order to get y by itself in the second equation, I'm gonna add x to each side, and now that's gonna leave me with x plus 3, okay? So what we're going to do is we're going to take this value of y equals, right, which is x plus 3, and substitute it into y for the other equation. So now we would have 3x plus, right, and I'm just going to put in parentheses here, x plus 3 equals -1. Okay, so our extra step from yesterday was just we're solving for the variable. All right, it wasn't just x or y equals. Now we're going to combine our like terms. 3x plus x is 4x. We subtract 3 from each side. We get 4x equals -4. We divide by 4, and x equals -1. Okay. Now for this part here, remember the last step said we wanted to substitute it in any one of the original. The reason we want to substitute in the original is in case we make a mistake here, it will show us when we plug it back in. Okay, so once again, doesn't matter which one we choose. I'm going to do the least work as I can here, so I don't do any multiplication. So I'm going to say negative of -1 plus y equals 3. A negative of -1 is 1. We subtract 1 from each side, so y equals 2. So our solution here is going to be -1, 2. All right, so that was our first example. Okay, here's our second example, example 2. All right, so we're going to say x minus y equals -4. All right, and our second equation here is going to be 2x plus y equals 4. Okay, so when we go through and look at these again, we can have the x or the y both have a coefficient of 1. Just because I'm going to solve for x in this equation here. So I'm going to say x minus y equals -4. To solve for y, solve for x, I'm going to add the y to each side. So that leaves me with x equals y minus 4. So I did that in the first equation, so I'm going to take this value here and plug it in. Notice for x now in my second equation. Okay, so now I'm going to say 2 times y minus 4 plus y equals 4. I'm going to distribute the 2. Sorry, wrong pen. So 2 times y is 2y. 2 times -4 is -8 plus y equals 4. I'm going to combine like terms. 2y plus y is 3y minus 8 equals 4. Oh, sorry. All right. Now I'm going to add the 8 to each side. 3y equals 12. Divide by 3. Y will equal 4. Okay. All right, once again, it doesn't matter which one we plug it into the original. I'm going to plug it into the first one. So x minus 4 equals -4. I'm going to add 4 to each side, and x is going to equal 0. So my solution is 0, 4. Okay. All right. Example 3. X plus y equals -2, and -3x plus y equals 6. Okay. Once again, it does not matter which variable we solve for. All right. I would either solve for the x or y in the first one, or the y in the second equation. All right, so I'm going to solve for y in the second equation. So if I solve for y in the second equation, I'm going to add 3x to each side, and that will give me y equals 3x plus 6. Okay, it does not matter which way you do it. I hope you understand that. All right, you could have solved for x or y in the first one. Our work will look a little different, but we'll still get the same solution. All right, so I'm going to take this value and plug it into y in the first equation. So now I'm going to have x plus 3x plus 6 equals -2. Combine our like terms. X plus 3x is 4x plus 6 equals -2. Subtract 6 on each side. 4x equals -8. We'll divide each side by 4 to get the x by itself. -8 divided by 4 is -2. All right, so now that we have our x value, we can plug it back in to get our y value. I'm going to plug it into this first one. -2 plus y equals -2. Add 2 to each side. Y equals 0, because -2 plus 2 is 0. So our solution is going to be -2, comma 0. All right. If we flip our paper over, we got one more example, then I'm gonna have you guys try the last one to add into your notes here. All right, so example 4 is gonna be negative 2x plus 2y equals negative 8. And our second equation is going to be 4x minus y equals 10. All right. So if we notice here, we don't have any variable here that just has a 1 as a coefficient. All we have here, all right, is something as a negative 1 as a coefficient, but that will totally still work, and it's our second best situation. So we're going to solve for y in the second equation. So we would minus 4x from each side, negative y equals negative 4x plus 10, but we want the y to be positive, so now we're going to divide everything by negative 1. So we'll now have y equals negative 4 divided by negative 1 is 4x, and 10 divided by negative 1 is negative 10. So we solve for y, and this is the value that we're going to plug into the first equation. Okay, so we'll have negative 2x plus 2 times 4x minus 10 equals negative 8. All right, we'll distribute here, so we'll have negative 2x. 2 times 4x is 8x, and 2 times negative 10 is negative 20. We combine our like terms. Negative 2 plus 8 is 6x minus 20 equals negative 8. Now we're going to add 20 to each side. So 6x equals 12. Negative 8 plus 20 is 12. And now we divide by 6. 12 divided by 6. So our x is 2. Okay? So now we need to plug our x in to get our y. All right? Does not matter which one we're going to do. All right, just for space here, I'm going to go through. I'm going to plug it into, let's plug it into the first equation. So we'll have negative 2 times 2 plus 2y equals negative 8. Negative 2 times 2 is negative 4. Okay. We're going to add the 4 to each side. So we'll have 2y equals negative 4. Divide by 2. Our y equals negative 2. So our solution for number 4 is 2, comma, negative 2. All right, so the last one here is going to be a you try. I want you to try this one and fill it in your notes, all right? And it'll be part of your notes that you're going to have to submit, all right? And this is example 5, and we're going to have 3x minus 2y equals 19, and our second equation is going to be x plus y equals 8. Okay, so this is a video for section 5.2, day 2, solving by substitution. If you have any questions, please let us know. Have a great day. We'll talk to you soon.